Welcome to this video in the Spectrum Protect Plus sizing series. This video covers what's new in the Spectrum Protect Plus 10.1.5 blueprints and sizer. Jim Smith is going to take you through that, so I'm going to go ahead and turn it over to him. Thanks.
And we have just published the Spectrum Protect Plus blueprints update for 10.1.5. There has been enough change in the blueprints that warrants an overview to highlight what's changed and why things have changed. And you can see from the agenda, I think the most popular question of the day is what's going on with developer works and how is this affecting the blueprints. We'll talk about that. Why are we making changes in this part of the product life cycle and obviously the what's changed. And we'll look specifically at a sizing example to demonstrate what effects these changes have had in the output that you'll be looking at. And then we'll quickly cover, we have a couple new workloads, Office 365 and Kubernetes. We'll quickly talk about what you can do with the sizing spreadsheet to size those. Developer work status. I threw in the disclaimer because this is work in progress and this is subject to change. As you can read, the blueprints, all the family of blueprints are going to be hosted as tech notes, i.e. on the IBM support website. This is the link for the Spectrum Protect blueprint. So that's the first thing. So the information, at least for the Spectrum Protect family of blueprints, has migrated. Motivation for changing. As I said, some can consider a significant amount of change in the blueprints. So what is motivating this? We've had a lot of field experience with Plus. It's getting used by lots of different customers now. And we are getting feedback about the memory considerations and the performance of deduplication. One of the major areas that has changed or motivations is the deduplication performance. And we will underscore and I'll point out what we've changed in the document, and we'll look at the changes in the actual sizing tool. But we want to highlight that the performance of deduplication is not going to be the same as compression. And there have been some changes in the GA code in 10.1.5 that help us better control how memory is used by ZFS, especially in terms of deduplication. So we're doing things like telling ZFS that the ARC space can be capped at this amount of memory, and that ARC space is to be used predominantly for metadata, which is predominantly made up of DDT entries and not for caching other things that are coming into the system. One of the things you might have heard about in ZFS 08, which is part of 10.1.5, is this concept of allocation class. From a steady state perspective, we have not found any benefit from using an allocation class, and therefore there's no recommendations to date in the blueprints about using that, because again, we don't see any value it's bringing to our steady state ingest workloads. One of the big changes is we're recommending smaller building blocks. So when you ran the sizing spreadsheet before, the spreadsheet would spit out the maximum size, either 400 terabytes for compression or 200 terabytes for deduplication. Based on what we've been recommending in the field, especially around deduplication, we've changed it so the spreadsheet will still go up to a maximum of 200 terabytes if you want to do that, but the recommendation coming out of the blueprint by default will be 100 terabytes for deduplication, and corollary will be 200 terabytes for compression. We've raised the memory recommendations. We're going to look at those in detail. And again, based on field feedback and deduplication we're seeing in the field, we've changed the default going to use from 2 to 1 to 1.5 to 1. Now, the recommendation on deduplication, this is right out of the white paper. I've highlighted what we've changed. The use of data deduplication requires strict adherence to the sizing specifications, i.e., if you're going to use deduplication, you really need to pay attention to the CPU and memory requirements that are laid out in this documentation. The other thing I want to highlight here is that this is the recommendation from IBM. Now, you certainly have to continue as we keep talking about deduplication, understand the benefits you're getting from deduplication, and we'll talk about this in a second, about the performance implications. Understand where it sits in the stack. Remember with Plus that almost all the workloads are incremental forever. Kubernetes now is the exception to that. So you're not seeing as much deduplication out of a system like this versus a system where you're doing more full backups. Also, understand that you're getting a lot of deduplication when you're doing repeated backups of similar things like full backups of VMs. And there's really nothing wrong with taking a position after you've reached steady state, maybe you're backing up 500 or 600 VMs, that probably not getting a lot of duplicate type data anymore because you've stopped ingesting full VMs. There is nothing wrong at some point with saying we can turn deduplication off because we're not in the savings anymore. We're predominantly in the incremental steady state or the log backup on the applications. Turning off deduplication is a very different recommendation than we don't recommend deduplication. I just wanted to highlight that. And then we've added some information about the resource requirements and especially how memory of the system is correlated to your performance from deduplication. What happens when deduplication tables exhaust memory? What will happen to backup performance? All right, some additional things that have changed, which we'll look at in a little more detail when we open the sizing tool. We've changed the reserve percentage. There are a lot of comments at 25%. It might be a good reserve percentage for a small vSnap repository. For bigger vSnap, 200 terabytes, 400 terabytes, 25% is a lot of space. Again, just to back up, when we give space over the vSnap repository, when the pool is initialized, there's a piece of space set aside. ZFS calls flop space, which is typically a 1/32, or I think it's like 3.5%, something like 3.25. And we also need to reserve space for snapshotting, for recovery when we're running reuse cases and we're cloning. So we need space for that. So that's the reason why there's a reserve in there. So we've moved away from a global reserve to a graduated reserve percentage based on the size of the vSnap. You'll see for 100 terabytes, it's going to be 15% instead of 25%. And again, this will be something you can override if you don't like our answer. Log backup calculations for the application logs, SQL, Oracle, et cetera, were broken in 10.1.4. The people that realized this were sizing. We're having to go back to the 10.1.3 blueprint, so that's been fixed. Blueprint documentation itself has been updated to refresh the store-wise parts. We've made some slight modifications in the way we present results, and we'll look at that in a bit. And we are also adding a new result, which is the back-end data rates for the primary workloads to understand the data rates you need for that data after it's compressed and deduplicated. Now it has to be written to the disk, what kind of data rates you need to sustain performance. And then I mentioned sizing new workloads. Back in 10.1.2 or 10.1.3, we went away from having individual tabs for Oracle, DB2, and SQL because for the most part, all these applications behave the same from a sizing perspective. Office 365 and Kubernetes are a little bit nuanced. So you can take some manual actions for Office 365. There's no concept of log backup, so you'd want to leave that off. And the Kubernetes, of course, you're doing snapshots, and then you're writing the snapshots periodically to the vSnap storage. Those periodic copies are full. To account for that in the spreadsheet, you just daily change rate at 100%. You also can't replicate and copy, offload, et cetera, Kubernetes data. So getting into the changes, I've taken table 2, which is the recommendations for the vSnap, the ADP proxy combo when you're using deduplication. Abbreviated the table a bit just to highlight that number one, the CPU requirements are not changing, but as you can see, the memory requirements are changing, in some instances changing quite a bit. I think we found in our research that if you go out and look on various blogs, you see numbers of 1.25, 1.5 gigabytes per terabyte of storage. We're still roughly in that area. We'll just caution that what we're looking at, for example, 120 terabytes to 100 terabytes, we tend to look at this as more of we need X number of gigabytes of memory for the dedupe tables, and then we need to add on to that, which you usually don't hear about in the blogs. You need to add on to that the memory needed for the proxy and for the vSnap server itself. This is the sizing example. We're going to concentrate. The sizing example in the blueprints talks about a 2-site deployment with VMware and SQL data in one site and Oracle data in the other site. Since we're looking at 100 terabyte front end, we're keeping backup data for 30 days. We're going to deduplicate it. We're looking at a sizing for 3 years. We plug in the numbers, and I'll just give you so the managed data, obviously the amount of data that's going to come into the system is not going to change. That hasn't changed between 10.14 and 10.15. That's the total amount of data over 3 years given growth and change rate in the front end of 100 terabytes. Compression is still 50% by default, so it's going to get halved as far as how much data has to be stored. Now you notice the data after deduplication in 10.14, that number, compression number was halved again, and now it's only 1.5 to 1. You're going to have a little more data to store because you don't have by default the same deduplication ratio, and then we have to tax on the reserve space, which was bigger in 10.14, 25%. 10.15, it's 15% based on the vSnap size. Again, notice that the vSnap size chosen was 200 in 10.14. That was the maximum size that we recommend, and now we're recommending the default, which is just one stop below that in photography terms, or 100. So that means in 10.14, to store this 136 terabytes of data, you needed one vSnap that's 200 terabytes, and obviously now you need 100 terabytes. And you can see the memory calculations. Before you needed 176 gigabytes, now you need 2 by 120 or 240. You can see the total CPU cores.
Blueprint document now where there's some clear wording that will say if you're going to use deduplication, you have to have the expectation that you'll have less performance than if it were compression only. Our goal here with this eFix we have upcoming with some deduplication enhancements is to allow, when you are using deduplication, that you can sustain performance that is half of what you would get if you were only using compression. So reality check numbers here. Let's say you had storage hardware capable of doing a gigabyte per second sequential write for the vSnap. That would be with compression only. We would want to be able to hold 500 megabytes per second when you're using deduplication. So the implications here are when you're doing a sizing that you may need more vSnaps to overcome that loss of throughput if you have the requirement that you must use deduplication. Here in the new version of the blueprint as well as the sizer, we've tried to steer the results to that outcome. In reducing the default size for the vSnap is a way to have the result be that you're going to end up with more vSnaps. There is also an impact to restore, and the same is true for protect, right? Any system that uses deduplication, one implication there is that reconstruction needs to happen on restore. And what that translates to is a more random I/O pattern hitting the disk. Because what was streaming in that backup time as a sequential write pattern has the behavior that certain portions of that match things that were already stored that are out in different regions of the storage. So at restore time, you have to reconstruct that. It's more random. The blueprints have been designed to accommodate that by having a lot of disk spindles. In general, the impact to restore is minimized by that. But there is an impact, right? You can always go and compare to, well, if I had not used deduplication, let me compare the restore rates.
So just quickly going through this, the first page has not too much has changed. There's some stuff on the bottom with the cloud offload not been implemented that we took out. The deduplication ratio, as you can see, is 1.5 to 1 now instead of 2 to 1, but you can still manipulate that. We're a little more aggressive with hover over help and saying if you're going to use deduplication, please make sure to read the blueprints and understand the recommendation. The vSnap reserve percentage is no longer here. We're going to carry that over in the sizing results and see that. So VMware, not too much has changed here in the spreadsheet. We have added this backend rate, which again will aggregate and bring into the sizing results. The other thing is that the blueprints were built for Protect, which was doing dedupe and compression. So we've just flipped the output. So you see the compression savings first and the dedupe savings second, and also flip the percentage and the number. Again, we're not calculating the reserve space yet. That's being moved when we sum up everything out in the sizing results. The application, we see similar changes with a couple of additional changes. The logs, we are estimating, backup logs. Look at the log estimate at 75%. We apply a different reduction savings of 50% against that and not the 67%. Why is that? Well, by default, we're just applying the compression savings. And I'll show you how to change that if you think that's not the best solution for you. We've basically broken out the logs and the reduction savings of the logs because they might not perform as well with compression and deduplication. Usability change here, you can go up here now and change this label. So if you save this, you can come back and say, oh yeah, this was my Microsoft Exchange. You can do that in all these tabs. So the sizing results now, a couple notes here. You'll see that preferred vSnap size still automatic by default, and you have this pull down. Since we're doing deduplication, we'll go to 200, but it has automatically picked the 100 terabytes for me, and I could change that. The reserve percentage, you'll see it's automatic. It's picked. Look down here, it's 15%. You can override that and change that if you want to make it lower or higher, 5% increments. Be aware that you're going to have to go into the Spectrum Protect UI and change the global settings at this point. So we go to Global Preferences, and you can actually change the thresholds when backups stop the target free space error. That's at which point the backups stop getting ingested because you're at the threshold. And you have the warning, which is usually 10% before that. So the point in the spreadsheet is, because we're changing the reserve percent, it might not match with those settings. So we're giving you these settings. We're saying, okay, set this setting to 15%, set this one to 25%. Also notice that we have the peak backend rate here calculated. Again, these tables have been slightly modified for readability. And the last thing is this secret macro here, the Advanced Settings tab, which some of you are aware of. There's a macro here, you can unhide that. And this was traditionally, if you wanted to change the global settings for deduplication and compression and use application-specific settings, you might have set dedupe to 33% for SQL and decided that SQL gets better deduplication or worse, so you can change that here. So the new thing here is this log data reduction. And again, this controls whether the logs get compressed or deduplicated, or we account for that. And as you see here, by default, we're setting the compression to yes. You can decide that that's not the best case, and they don't compress or they deduplicate, and you can just simply come and toggle that here. This was not meant to be a how to use the spreadsheet demonstration, just to highlight what's changed between 10.1.5 and 10.1.4.
Be sure to check out the other videos in our Spectrum Protect Plus sizing series. Thanks so much.